You can just, squeeze them and they will clamp and you cannot open it anymore. Why do you want it so that you cannot open it anymore? Because you suspect that if you put that clamp on the wall and people can open it, chances are that villagers will open it and sell it to the as junk, as metal junk. So that's the level of poverty in the region. And these are the some solutions for the roof to behave as a diaphragm. Now, again, will it work? Does it have an impact potential? Yes, it does, and it may or may not work, but it is an idea that needs to be tested because at the time nobody is doing anything, and there are schools there, and there's this 4 plus 4 plus 4 plus 4 plus 4 plus 4 system now that 5-year-olds are starting school, and you cannot carry them to nearby villages because they have potty training problems, and they are opening again the schools that they closed a long time ago. And these are the buildings that absolutely nobody, and I know because I went to the Ministry of Education and I talked to people, they're not doing anything. I said, you cannot do anything about those buildings. But we should, because you're architects, I'm an engineer, we should work together and find solutions to problems like these. If not, what is our education or training worth? And how about those buildings? What can we do? And these are the typical solutions, conventional solutions. And I have already told you about this design of mine, which is still to be tested, and I hope to test it in the near future. And this is an innovative solution. We have found out that, as here, I should say, if it's an empty frame, if there's no wall, this is the resistance. If it's a full frame, if there's wall, it's this. As you can see, it's much, much higher. So, if I can protect these walls from demolition, from destruction, then I can save the building. And to do that, we thought of a rail system where, and this has to be easy because otherwise people don't apply. We install the rails, and we have these metal ties. We insert them, rotate them to lock in place, and slide them on the mortar bed. Easy enough. And this is a project that is under review for an EU project, and we also filed a patent application for this. It may not be used, may or may not, but still it is a solution that is worth investigation. And we are engineers, and this is another design, and we are here to find solutions to problems. Okay, how about hundreds of thousands, millions of buildings? We have 7 million of them, and $400 billion of market in this Urban Transformation Law Act. Well, and this is how we collect information about them. Forms. People go there, what's your name, how many floors, this, that. Well, we said, this is not going to work. Why? Because you cannot collect this, you cannot store this, you cannot transfer this, you cannot analyze it, you cannot do anything about it. You're just wasting your time and money. What else can we do? Tablets. My 4-year-old does wonders with tablet PC. So why not use it? We go to the site, take pictures, do image processing, all sorts of gadgets, laser meters for sizing, and once the technician on the site hits OK, and it automatically is uploaded to a database where you can online see if you have information about this building. It is a central database where you can monitor every building with the GIS support, where you can get the information and see what the status about that building. And you can use this after earthquake. You can say, okay, this was the condition, it's now this, and just color code if you can enter the building, if you need to do an investigation before you go into the building, or you don't go into the building. And these are before, right after an earthquake, before anybody comes on the site. And these are technology, everybody is using these, UPS is using this, and not civil engineers or architects. Well, architects are using it more than we do. since the architects are more than civil engineers here. Now, this is the proposed system. So this is Turkey, Ankara, that building, get the type of building, the information, and once an earthquake happens, you quickly determine if it's go. What else can you do? You put some sensors on the building and determine, based on the vibration characteristics of a building, you can see if that building is okay or not okay after an earthquake. And this is a study that we are doing right now, for example, at Atılım University. In fact, when I leave here, I will go back to my lab to continue this test. And this is a frame, as you can see. There are two columns and a beam, and we have 1, 2, 3, 4, 5, 6, 7, 8 accelerometers that measures accelerations. So what I do is, I have a load cell there, I push this frame, I give it some damage, and then I have a hammer, I hit it with the hammer, and I measure the acceleration from these accelerometers, and I see if the vibration characteristics of the frame has changed when I gave it damage. Now with that information, what do I do? If I can see that I can detect damage with vibration characteristics, now I can take it to buildings. And I put a sensor on the building, an accelerometer, and earthquake happens, and after the earthquake, I measure the vibrations and I say this building is damaged or not, just by looking at the vibration characteristics. So I hope I haven't bored you much. We have lost about 15% of the audience, which is not bad. So concluding remarks, considering that you had to come here for the signature, 15% is pretty acceptable. Material innovations are the main driving force behind future breakthroughs in construction technology. And this is, well, these are the conclusions, but in essence, I should say, you're here to make a difference. And that you can do it many times. As if you ask me what my profession is investigating, my specialty, what I'm an expert on. I'm one of the foremost experts in the world, probably within top 10, on FRP debonding problems in concrete and steel substrates, which means nothing. It can give me a pretty secure career in an American university, which many people are looking for. But for me, it doesn't mean anything. And my paper from my PhD is cited more than 80 times. And what does it mean? It doesn't mean much at MIT scale. But if you look at Middle East Technical University Civil Engineering Department, in the history of the department, no paper is cited more than 50 times. So it is an impact, but it doesn't mean anything. We need to prioritize. You need to find high impact problems, worthy problems, and direct your energy and brains to solving those problems. It may work out, it may not, as often happens, it doesn't, because research equals frustration. But when you do find the solution, it's a quite rewarding experience. Thank you for your patience, and again for inviting me here. And I hope I have met your expectations next time I come to you. If you have any questions, I would be happy to answer those.
Ben sadece çok teşekkür edeceğim. Yani çünkü biz bu plastiklerin ya da FRP'lerin bu kadar etkin kullanıldığını şimdi anlamıştım yani.
Yes.
Yani biliyoruz kabuk tasarımında falan kullanılıyor ama şey için güçlendirme amaçlı.
Evet.
Az oluyor.
Kalınlıkları ne kadar oluyor?
Milimetre. Milimetre.
Yeterli oluyor.
Evet. Çünkü çelikten bir 5 ila 10 kat daha kuvvetli bir malzeme. Problemi yok mu? Var. Problemi çünkü lineer elastik davranır. Şimdi çelikle karşılaştırdığınız zaman çelik bir yere kadar lineer elastik davranır. Ondan sonra plastik olur. Böyle uzunca bir gider ama o gidiş bayağı uzunca bir gidiştir. Çünkü 1 metrelik çeliği çektiğiniz zaman 25 santim uzar. Ama FRP öyle değil. Yani 1 metrelik FRP'yi çektiğiniz zaman 2 santimden fazla uzamaz. Ama Allah'tan normal tasarımda bize 2 santimden fazlası da lazım değil zaten. Öyle olunca da amacı gerçekleştiriyor. Yani kullanılmasına uygun olduğu uygulamalar var, uygun olmadığı uygulamalar var. Onları iyi bilerek işte mühendislikle uygulamak lazım.
Ne dersiniz? Şimdi başta gösterdiğiniz özellikle kırsal bölgede insanların şimdiye kadar neredeyse binlerce yıldır aynı teknolojiyle
Evet.
onların o bilgilerin içine, işte ne bileyim, harçların içine biraz farklı karıştırması falan gibi eğitilmeleri, bu konuda donatılması, onların o konuda ne dersiniz?
Yani o konuda yöreye gittiğiniz zaman diyorsunuz ki ya kardeşim hiç mi bir şey öğrenmedin? Ama öğrenmişleri var, öğrenmemişleri var. Yıkılan binalara baktığınız zaman işte bu hani wisdom derler ya, old wisdom. Adamlar bakmışlar ki ya bu binanın şurada bakın ahşap şeyler var, hatırlar var. Bu hatırların önemini, işlevini çözmüşler. Fakat yani ve de çok da faydalı, yani binanın şeyi için, bütünlüğü için, performansı için son derece önemli şeyler var. Fakat şurada görüyorsunuz mesela bakın eklemeyi yaparken onları birbirine bağlamamış. Bağlaman gerekiyor. Evet. Ondan sonra onların sürekli olması gerekiyor. Yani 2 tane altın var. Onların da birbirine bağlanması gerekiyor ki değişik bol duvar katmanların arasında bir bağlantı olsun. Ne yapıyor? Kalın yapıyorsun. Burada 60 santim yaptın. 60 santim yaptın ama 30-30 yaptın. Aradan ayrılıyor. Onları birbirine bağlamış olsan, bu hatırlar zaten şey yapmıyor. Bir tek böyle gitmiyor. Bir de iç tarafa doğru, 2 tarafta var bunlar. Birbirini bağlıyor. Yani duvarı hem kalınlığında bağlıyor, hem de şey boyunca da, uzunluğu boyunca da. Şimdi sen buraya ek yapar da bunu birbirine bağlamazsan çatlak hemen oradan arasından geçiveriyor. Bir de bunları birbirine bağlamamışsan zaten hiçbir şey demeden duvar ortadan ikiye ayrılıyor. Ve gördüğünüz zaman yani bunu yüzyıllardır yapıyorsunuz, bin yıllardır yapıyorsunuz. Yani hiç mi dikkat etmez insan diyorsunuz? Edilmiyor.
Bunu bilen, icat eden, bulmuş, uygulayan, unutmuş.
Evet, yani işte ne lazım? Ermeni ustalar lazım o işi yapmaya. Çok teşekkür ederim. Sağ olun. Tebrik ederim. Estağfurullah. Estağfurullah. Başka soru yoksa ben de azat edebilirim dinleyicilerime. Bayağı